Okay, what if the single most common measurement you use in your clinic is also the most misunderstood? I'm talking about the decibel. It seems simple, right? But it's hiding a secret. A secret that once you get it, will completely change how you look at every single audiogram. So in the next few minutes, we're not just going to define the decibel. No, we're going to decode it so you can walk away and use it with total confidence. Let's get started.
All right, let's kick things off with a bit of a challenge. We're about to pull back the curtain on the hidden secret of sound measurement, and I promise you, by the end of this, you'll never look at your audiometer the same way again. So, are you ready to learn the one simple trick that tames the entire massive world of sound? It might seem incredibly complex right now, but is all built on one really elegant and powerful idea. Just look at this number, 100 trillion. That is the incredible dynamic range of human hearing, the ratio between the softest whisper we can possibly detect and a sound so loud it's actually painful. Now, how on earth are you supposed to graph that for a patient? You can't. It's totally unmanageable. We clearly need a way to tame this beast of a number. We need a system that can shrink this colossal range down to a simple, manageable scale that we can actually use with our patients. And that is exactly why the decibel was invented. So how does it work? Well, the secret weapon is a concept you probably remember from math class, but trust me, we're about to give it a practical, clinical superpower. Let's talk about logarithms. Forget all the complicated formulas from your textbooks. For what we need, a logarithm is just a simple shortcut. All it does is ask one question. How many zeros are in this number? That's it. It's a tool designed purely to make scary big numbers small and friendly. Look at how beautifully this works. The log of 100 is 2, because you guessed it, 100 has 2 zeros. The log of 1,000 is 3, because it has 3 zeros. And what about the log of 1? Well, it has no zeros, so its log is 0. This simple trick is what shrinks that 100 trillion range down to a workable clinical scale of about 0 to 140. Okay, before we meet the different types of decibels, let's lock in these 5 fundamental truths. A decibel is always a ratio. It uses a logarithm, which makes it nonlinear, and it's a super important detail for later. And because it's a ratio, it always needs a reference point. It's a relative unit, not an absolute one. Got it? Good. With that foundation set, let's meet the family. You see, you shouldn't think of the decibel as just one thing. Think of it more like a toolkit with 4 different instruments, each one perfectly designed for a specific job. These are the 4 faces of the decibel that you will use every single day in the clinic. First up, dBIL, or intensity level. This one is pure physics. It's all about raw power, measuring the amount of sound energy hitting a certain area. Think of it as measuring the brute force of the sound wave itself. Next, we have dB/SPL, or sound pressure level. Now, this is what you measure out in the real world. It's the physical pressure that sound waves create in the air. That sound level meter measuring noise in a factory or at a concert, yeah, it's reading in dB/SPL. And now we step into the clinic. dBHL, or hearing level, is the language of the audiogram. Instead of pure physics, it's anchored to human hearing. It answers one simple question. How loud is this sound compared to what a person with perfect hearing can just barely detect? And here's the key. 0 dBHL is not silence. It's the starting line for normal hearing. And finally, we have dBSL, or sensation level. This one is completely personalized. It uses the patient's own hearing threshold as the reference point. It answers the question, how loud is this sound for this specific patient? This table brings it all together. Feel free to grab a screenshot for your notes. You can see each decibel type, its unique reference point, and exactly where you'll use it. Notice the split here. IL and SPL are based on pure physics. HL and SL are all about the patient's perception. All right, theory's done. Now let's get practical and bust some of the common myths that trip up almost every student. This is where this knowledge really becomes a clinical tool. Because the decibel scale is logarithmic, you can't just add values together like you normally would. If you have one speaker playing at 60 dBIL and you add a second identical one, the total isn't 120, it's 63. Here's the rule. Doubling the sound intensity always adds 3 dB. And because of the physics linking intensity and pressure, doubling the sound pressure always adds 6 dB. Remember that one. It is a classic exam question. And now for the single biggest misconception about the decibel. When you see 0 dBHL on an audiogram, does that mean the patient heard nothing? That the stimulus was total silence? Absolutely not. Remember, a decibel is a ratio. 0 decibels simply means the sound being presented is exactly equal to the reference sound. The ratio is 1 to 1. And what did we say about the logarithm of 1? It's 0. So 0 dB means the sound is definitely there and it's perfectly matched to that reference level. This brings us to the clinical definition of threshold, which is the foundation for both dBHL and dBSL. A patient's threshold isn't the softest sound they can ever hear. It's the level so quiet that they only catch it about 50% of the time. This statistical approach is what gives us a reliable and repeatable measurement. And to put all this into a real-world context, just look at the scale in dB SPL. Normal conversation is hanging out around 60 dB. A rock concert can easily hit 120 dB. And the point where sound becomes physically painful is right around 140 dB. This just perfectly shows how that logarithmic scale takes our entire auditory world and makes it easy to grasp. Okay, time for a quick clinical calculation. Your patient's threshold at 1000 Hz is 30 dB HL. You decide you want to present a word list at 70 dB HL. What is the sensation level, or dBSL, of that word list? The answer is 40 dBSL. It's just simple subtraction. The presentation level in HL minus the patient's threshold in HL. So 70 minus 30 equals 40. This means the words were presented 40 decibels above that patient's unique threshold. Come on, let's do a quick quiz to lock this in. If you double the sound intensity, how many decibels does the dBIL increase by? The answer is C, 3 dB. Remember that doubling rule: double the intensity, add 3 dB. And there you have it. You've decoded the language of sound. The decibel is no longer some confusing number. It's a powerful tool for understanding hearing. Just remember, it's all about ratios, references, and logarithms. Now that you've mastered this, what complex topic should we demystify next? Let me know in the comments. Thanks for watching.